Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. This is Lesson 5, the zero product property. Product being multiplied. Zero is a number. Zero times something is the zero product property. Opening exercise. Consider the equation. A times B times C times D equals 0. What values of A, B, C, and D would make the equation true? Okay, well, there's infinite solutions. So if I let A equals 0 and B, C, and D non-zero numbers, it would look like this. 0 times, let B equal, I don't know, 2, and C equal -7, and D equal 5. Doesn't matter, any number. If A is 0, then it would be 0 times 2 times -7 times, let's do this, 5. Well, 0 times 2 is 0. 0 times -7 is 0. 0 times 5 is 0. So if A is 0, that would be true. Okay. But I then could say, let A equal 2 and B equals 0. Well, then it'd be 2 times 0 times -7 times 5 equals 0. 2 times 0 is 0. 0 times -7 is 0. 0 times 5 is 0. You get the idea? It does not matter which number is 0 as long as one of them is. It could be 0 times 3 times 2, and that would be 0 times 0 is 0 times 3 is 0 times 2 is 0. It could be 0 times 3 times 0 equals 0. Or it could be all of them 0. So the answer would be, as long as one of them is 0, the answer will always be 0. One or more are 0. Okay, exercise 1 through 4. When it says exercise, that means do it on your own. Pause the video, see if you can do this, come back and see how you did. All right, assuming you have done this, it says find the value of C and D that satisfy each of the following equations. There may be more than one correct answer. So I would say C equals 0 and D equals 7. Okay, so since C is 0, that'd be 0 times 7 equals 0, and that is true. How about C equals 8 and D equals 0? Well, then that would be 8 times 0 equals 0. Okay, number 2. For what values of C and D would this equal 2? Well, I believe there would be an infinite number of solutions to this. Let's see. Let's choose a value. Let's let C equal, it can't be 5 though. C cannot equal 5 because 5 minus 5 is 0 and 0 times anything is. So I know C cannot equal 0. I'm sorry. C cannot be equal to 5. That is one thing that I do know. C could not equal 5. All right. D cannot equal 0. Those are my only two restrictions on this problem. C can't equal 5, D can't equal 0, because then it'd be 0 and not 2. But if C was, let's say C equals 6, then I'd have 6 minus 5 times D equals 2, and that'd be 1 times D equals 2, so therefore D would equal 2, because 1 times 2 is 2. Or I could show it by dividing both sides by 1. Or 1D equals 2 is D equals 2. Whatever way you want to look at it. There are infinite many solutions to this. Let's do another one. How about I pick D to be 7. C. So if I have C minus 5 times 7 equals 2, then I have to find the value of C that makes this true. And so in order to do this, this is multiplication, so I remember my order of operations in reverse, because we're doing the inverse across an equal sign. I would divide both sides by 7. And then I would get these to cancel. and I get c minus 5 equals 2 over 7. I'd add 5 to both sides. So c equals 2/7 plus, and since I have a fraction, I have to add fractions that have the same denominator. And in order to make 5 a denominator of 7, you just multiply 5 times 7 and get 35 sevenths. 35 divided by 7 is 5. So therefore c would have to be 37 over 7. Okay. It did not say integers here, so we're okay. So if c was 37 sevenths and d was 7, that would be true as well. So there are infinitely many solutions. Throw a number in there, solve it algebraically, find the other variable. Number 3. Now we have the zero product property. This is easy. I already spoke about this in the last problem. If I make what's in the parentheses 0, in other words, c equals 5, because 5 minus 5 is 0, 0 times no matter what d is will always equal 0. I could also make d equal to 0, and no matter what c is, it could be 1,000,000, and 5 minus 5 equals 1,000,000. 1,000,000 times 0 is 0. Okay, so these are the two values that would make that true. Okay, number 4. In order to make this 0, I need this to equal 0, and that would be c equals 5. And it doesn't matter what this is. 0 times anything is 0. And in order to make the d plus 3 0, d would have to equal -3. -3 plus 3 is 0. That is the additive inverse property that gives us the additive identity of 0. Okay. So if c equals 5 here and d equals -3, that would also be true. Okay, example 1. For each of the related questions below, use what you know about the zero product property to find the answers. A, the area of a rectangle can be represented by this quadratic. If the dimensions of the rectangle are known to be the linear factors of the expression, if the dimensions of the rectangle are known to be the linear factors of the expression, write each dimension in the of this rectangle as a binomial. Write the area in terms of the product of the two binomials. Okay. So what they're asking us to do here is factor this into linear terms. So whenever I want to factor something, I always just put this here. My first term is x squared, so I know it's x and x. And factors of c that add up to b. So factors of -3 that add up to... So factors of 3 are 1 and 3 because it's prime. And they have to add up to 2. So this would be plus 3 minus 1. All right, so those are linear. That's x minus 1, slope of 1, y-intercept of -1, slope of 1, y-intercept of 3. Those are two linear expressions. Okay, write each dimension of this rectangle as a binomial. Write the area in terms of the product of the two binomials. Okay, so the factors of x squared plus 2x minus 3 are x minus 1 and x plus 3. So the dimensions of the rectangle are x minus 1 and x plus 3. So next thing we need to do is, a rectangle looks something like this, and, well, which would be bigger? If x is 5, 5 minus 1 is 4. If x was 5, 5 plus 3 is 8. So this is the longer side, the one that we're adding 3 to x, and this is the shorter side. So there's our rectangle diagram. It says, draw and label diagram that represents the rectangle's area. Booyah. Okay. So if we're going to do algebra tiles now for B, I guess that's not what they're asking there. Why did that not turn red? That's better. All right. Draw and label a diagram that represents the rectangle's area. All right. So we have x minus 1 and we have x plus 3. So if I were to do this again as a rectangle over here, let me put x minus 1 over here. And this is just x. And then we're going to add 3 over here. So I don't know if x is 3 or what it is, so I'll make it a different size. So there's x plus 3, and here's x minus 1. But in order to make an x, so I'm making this a square, this piece here is a perfect square, that's value x, then I'd have to make this plus 1 here, because x minus 1 plus 1 is x, so this whole side is x. Does that make sense to everybody? This whole thing adds up to x. X minus 1 and 1 is equal to x. Okay, so then we have this over here because we want a rectangle. So there it is. A little messy, but now we multiply. X minus 1 times x is x squared minus x. And then multiply it by 3, we get 3x minus 3. And 1 times x is x, and 1 times 3 is 3. Okay, so there is the area of the rectangle diagram. So if we combined all of these, it'd be x squared minus x plus x canceled, plus 3x, and minus 3 plus 3 cancel. Interesting. Anyhow. Okay, so part C says, suppose the rectangle's area is 21 square units. Can you find the dimensions of the rectangle? Okay, the area of the rectangle is x squared plus 2x minus 3. So I'm going to write that. X squared plus 2x minus 3. And if we know that equals 21, then we set the area expression equal to that. So the answer is yes. So that would be equals 21. X squared plus 2x minus 3 equals 21. Okay, then D says to rewrite the equation so that it is equal to 0 and solve. We cannot solve quadratic equations unless they're equal to 0. We want them equal to 0 because we're trying to find what values of x will make the equation 0, and that leads up to graphing and finding roots or solutions or zeros to the problem. So in order to rewrite this and get 0 on this side, I would have to subtract 21 from both sides. And in doing so, I will get x squared plus 2x, negative 3 minus 21 is negative 24 equals 0. Okay, so now I rewrote the equation so it's equal to 0 and solve. So now I have a leading coefficient of 1, so I can just do factors of c that add up to b. So I put an x here, I put an x here. Factors of 24 that add up to 2, and it's negative, so I have a positive and a negative, and the positive will be bigger, and that would be 6 times 4, and 6 minus 4 is 2. Okay, we're not done yet. The zero product property is what we're learning in this step, in this lesson. So I want to know what will make these two multiples, or the factored form, equal to 0. What x's will make this true? Well, if this is 0, it's true, or if this is 0, it's true. They can't both be 0 at the same time because x's are equal. So in this case, this x would have to equal negative 6, because negative 6 plus 6 is 0. And this one would be x equals 4. So what are the actual dimensions of the rectangle? Okay, so this is what we had. X minus 1, x plus 3 are the lengths, the dimensions in terms of x. So I'm going to bring that over, x minus 1 and x plus 3. So I will write that x minus 1 and x plus 3. So the dimensions would be, if I use the 4 minus 1 is 3, and 4 plus 3 is 7. 3 times 7 is 21. Okay, and if I do it again with the other one, x minus 1, x plus 3, and I plug in the negative 6, then I'd have negative 6 minus 1, which is negative 7. And then if I plugged in negative 6 over here, negative 6 plus 3 is negative 3. And negative 7 times negative 3 is also 21. But, rewrite this equation. Okay, what are the actual dimensions of the rectangle? Can either of these work? The answer is no. If these are lengths, this is a negative value. Length, distance can never be negative, so this is what's called an extraneous solution. Okay, F. A smaller rectangle can fit inside the first rectangle, and it has an area that can be represented by the expression x squared minus 4x minus 5. If the dimensions of the rectangle are known to be in the linear factors of the expression, what are the dimensions of the smaller rectangle in terms of x? So what they're saying is factor. So first term is x squared, so it's x and x. We have a negative here, so it's plus minus, and the negative means the negative is the larger absolute value. Factors of 5 that add up to 4, and that would be minus 5 plus 1. All right. So a smaller rectangle can fit inside the first, and it has an area that can be represented by this. If the dimensions of the rectangle are known to be linear factors of the expression, what are the dimensions of the smaller rectangle in terms of x? And there they are, x plus 1 times x minus 5. Okay, G says, what value for x would make the smaller rectangle have an area of 1/3 that of the larger? Well, the area of the larger rectangle was 21. 1/3 of 21, 1/3 times 21, or that's same as 21 divided by 3 equals 7. So we're looking for an area of 7. So I'm going to set this equal to 7. Not that. Hang on. I'm going to set that equal to 7. I'm going to set the original equal to 7. So I write x squared minus 4x minus 5 equals 7. Okay, what do we do next? We're solving for a quadratic. This must equal 0, so we can use the zero product property. I will subtract 7 from both sides, and now I get x squared minus 4x minus 12 equals 0. I will do my factoring. Factors of C that add up to, factors of C that add up to B. C is negative, so one's positive, one is negative, and B is negative, so the larger factor of 12 is the negative factor. Factors of 12. 1, 12, 2, 6, 3, 4, and I want a difference of 4. It's right here where 6 is negative and 2 is positive. 2 minus 6 is negative 4. 2 times negative 6 is negative 12. So x equals negative 2 or x equals 6. Okay, we're talking about length here. So I will not use the negative value, negative 2. So the answer is 6. Okay, cannot have a negative length. Okay, because if I plug this negative 2 in here, I get 0. That's okay, but if I put negative 2 here, I get a side length of negative 8. I can't have a negative side length. So if I plug in 6 to both of these, I get 0 and 8. 8 is positive. It can be a positive length. Okay, this is an exercise, so that means try it on your own. Pause the video, come back, see if you did it correctly. And here we go. I'm going to assume you paused and did this already. So I always want this equal to 0 first, so I'm going to add 5. Add 5. and I get x squared minus 11x plus 24 equals 0. I don't know why my 4's keep doing that. It jumps and connects it. And equals 0. Okay? I'm going to factor. Factors of c that add up to b. They're both negative because b is negative and c is positive. So I want factors of 24, which are 1 times 24. That adds up to 25. I want 11. 2 times 12 adds up to 13. I want 11. 3 times 8 is 24. I want 11. That is 11, so it's 3 and 8. Okay, this was negative 24. Well, it was positive 24, so they can both be negative, both be positive, but we wanted the negative, so I should just do that. Okay, so x equals 3 or x equals 8. Number 6. It's already equal to 0. And I want to look at this as a whole. And I look at this and I can see what I can factor out. Always look for greatest common factors. There's an x in each term. I will factor out one of those x's. 7x squared divided by x is 7x. X divided by x is 1. So in this case, if x equals 0, 0 times whatever, 7 times 0 is 0 plus 1 is 1. 0 times 1 is 0. That's true. Or x can equal, I'm not going to just jump into this. I will put the answer. It's going to be negative 1/7. Okay, and in order to figure this out, if you don't understand that, is 7x plus 1 equals 0. Subtract 1, subtract 1. We're solving for x. These cancel. And then I divide by 7, and boom, x equals negative 1/7. Okay? But whenever you have a parentheses and a linear equation like this, or linear expression, I should say, then the coefficient becomes the denominator of the solution. And if you were doing my beats method in the prior lesson, you see that's what I'm doing every time. All right, number 7. 7 showing a lot of 7s, or factors of 7, or multiples of 7, so I will factor out a 7. And this has an r, and this has an r. So, first thing I'm going to do is set it equal to 0 by adding 7 to both sides. 7r squared minus 14 minus 14r. Now remember, be careful. Do not add 7 to 14 and say that's negative 7r. 7 does not have an r. It is my constant. Think of this as plus 0 at the end of this, and you're adding 7 to 0, so now it's plus 7, and negative 7 plus 7 is 0. Now I will factor out a 7 and get r squared minus 2r plus 1 equals 0. And then I will factor this part out. And factors of 1, well, that's easy. It's 1 times 1. And the middle term is negative. That means they're both negative. Negative times negative is positive. Negative 1 plus negative 1 is negative 2. So therefore, r equals 1, or r equals 1. That is called a double root. We'll get to that later, but I will just mention it. It's called a double root when they're equal. Okay. Number 8. I have a 2, I have a 5, I have a 12. 2 will not go into 5, 5 will not go into anything, so there is no common denominator. I am going to use my beats method. A equals 2. Let me rewrite that again. Every time I write an equal sign, it looks like less than. B equals 5, and C equals negative 12. So I'm going to do my beats method. Factors of A times C, negative 24. Did it again. Okay, factors of negative 24 that add up to a positive number, that means my smaller number is negative. Negative 1 times 24, if you add them, it's 23. Negative 2 times 12, if you add them, it's 10. Negative 3 times 8, if you add them, it is 5. There is my number. Those are my numbers I need. Whoops, not equals. D minus 3, D plus 8. But don't forget this 2. Divide by 2, divide by 2. If it doesn't divide by 2, it's your coefficient. If it does divide by 2, simplify. Okay. So I have 2d minus 3 and d plus 4. And I should have been writing, let me get rid of my table again. It's in the way. Okay. I should be writing equals 0, equals 0, equals 0 every time. And, okay, I'm not done. I should not have circled that. Let me just erase this piece. All right, so now I need to solve for D. Now remember what I said. In order to do this quickly, you can do it algebraically if you're not comfortable. Set each one equal to 0. Let's just do that for now. And solve for the variable. These cancel. D equals negative 4. Okay. And since we're not talking about lengths of rectangles anymore, these are just quadratic equations, we can get a negative solution. So D equals 3 halves or D equals negative 4. Okay, that is the end of lesson 5. Review the lesson summary, make sure it makes sense to you. This is a really important property, and go to your problem set.